All right. So let's take a look at this problem number 15. It's a little bit different than the previous problems. They gave us an equation and told us to describe the transformations. Well, here they're describing the transformations and asking us to come up with the final equation. So this parent function is the quadratic function, and in my first transformation, it's saying shift the graph of f 4 units to the right. So let's call this first transformation just G1, and shifting it to the right, I know that it's minus 4, not plus 4, because it's bizarre in its behavior. So what this function f does is it takes the input, no matter what you give it, and it squares it. We're giving it x plus 4, so it's going to square x plus 4. So if I were to graph this quantity x plus 4 squared and describe it with relationship to the parent function, it would be a shift to the left 4 units. Now, we're going to take this result and build a new graph that is, what's the next transformation? It's a vertical stretch by a factor of 3. So we're going to multiply vertical stretches, multiply the output of the function, not the input. So the output of G1, and G1 we know to be this x plus 4 quantity squared, so we're just multiplying that by 3. Now, we're done. So I could have called that, because that's all we had to do. We just had 2 transformations, our sequence. So I'm going to come back and just call that my final answer, G. I could have left it as G2. So this G of x is equal to 3 times x plus 4 quantity squared. Let's go to the Desmos graphing calculator to illustrate that, hey, we do have the correct answer, or that it does seem reasonable. So it asked me to start with the parent function of x squared. So there's my parent function. And it said to obtain, to shift this graph to the right 4 units. So I called that a new function, and I just called it G1. And I knew that shifting it to the right was not to add 4, but to subtract 4 from the domain. So I knew that the x squared was the graph was a parabola with its vertex at the origin, and the minus 4 is a shift to the right 4 units. And that is the same thing as if I had just said x minus 4 quantity squared. If this graph that I result, I'm using that function notation there, and you can see that it's x minus 4 quantity squared is the same thing. So then I'm taking this graph of G1 that I got by shifting it to the look, that says plus 4 and I typed in minus 4. Oops, sorry about that. So it was a shift. I should read, oh wait, to the right 4 units. Oh, I was right. I'm wrong here. If I want to shift this to the right, I need this to be minus, and let's come back and make my correction. Hopefully it's not confusing you too much, that I should have had a minus sign right there, because that's actually a shift to the right. So that means that that minus sign is going to carry all the way through. So my first answer was wrong. So I'm glad that we're playing around with this graphing calculator. All right. So this next sequence was to vertically stretch it by a factor of 3. So 3 times that previous graph like that. All right, so let's see if this final graph really fits the description. We start with the parent function that was x squared. The minus 4 is a shift to the right 4 units, and multiplying it by 3 is then a vertical stretch. So is that the same graph as 3 times the quantity x minus 4 squared? And you can see that it is. That here's this graph in black, and there it is in orange, and we started with the x squared, we shifted it to the right, then we vertically stretched it, and that's the resulting graph, which the equation that we get is 3 times the quantity. And I don't need to square out that x minus. I like it to be in this form. If I would take x minus 4 times x minus 4 and write that as x squared minus 8x plus 16, I need this to be in vertex form. I need this to be in that form to be able to see these transformations. So that's my final answer for problem number 15. Sorry about that sign error. It's to the right, so that should be negative.